Hi everyone and welcome back. So here we are talking about phase 2. There we are going to split the resolvers, the schema definitions, and we'll combine them and we'll pass this to the Apollo server. Okay, this is what we discussed. So all the type definitions, all the resolvers, and we will also talk about the third argument, which is a context. Okay, so context is something which you can pass like a common data source. You are connecting to the Mongoose, MongoDB, MySQL, Postgres. So you always need to pass some meta information, some database connection information. All these things you can pass here. A simple example is you are getting a JWT token from each and every user. You can decode that token and you can pass that information in each and every request. So you don't need to handle that at a resolver level. So all those information you can pass in the context. Context, like it's like returning a promise here. I'm just returning the models, but you can write some async function. You can call async function inside it, get the data, collect the data, and then feed the data in the context so that each and every resolver can access this data. This data can be your MongoDB models, MySQL entities, or MySQL connection, MongoDB connection, anything, or some metadata about the logged in user. Okay, so now what we will do is in SRC we will create the folders like models, and then we will also create a schema and resolvers. Right now we are planning to split all these things in a separate folders. So in models we can talk about two different models, right? Those models will be, let's say, user model and message model. So we'll create user and message. It can be a simple user model and then there is a message model, and we are exporting both of these with the MongoDB connection. So I will connect MongoDB in the index. Then we have a resolvers, right? Resolvers can be, let's say, a user resolver and the message resolver. Same, we will do user.js. And we'll combine them in the index.js. We have the schema definition. In the schema definition, we'll again have the same set of folders, user and message. User and message are two MongoDB models. And we'll combine both the schema using merge in the index.js. Now let's talk about the type definitions first. Okay, so in the user definition, first of all, what we need to do is we need to import GQL. Let's go to user, and how we define the schema is simple. Import GQL, and here I'm using Babel to transfile this ES6 code to ES5. I mean, we are importing in the ES6 style. Apollo server express, that is correct, and we will do export default GQL and backticks. Inside this we will define our types. So our type can be simple. Let's see what all types we are going to have. We have the user, right? So simple type user of type, this is an object type, right? This is a type of an object. So here we have an ID which is required. Why it is creating a problem? Export default GQL. Okay, we'll see about it. Export default GQL, and we have this type user. Now what we need to do is, because now we are dividing the schema definition in each and every file, right? And finally we are going to merge them. So for query and mutation, we are going to use extend keyword. Extend type query, and you define the queries here. Similarly, extend type mutation, define your mutation here. Okay, and all the mutations we will define here, the query and all the types we have. So in the types we have a user. We can also have another type which is token. Like once user is logged in, we should be able to return some token string. Token is of type string and that is required. ID is also required in the user. So in the user object we have a username of type string, an email of type string, many more fields. Okay, in the query, like what all different queries we are triggering, I have a simple query is users, give me all the users in an array format. So I will just say give me the users, give me user by ID. So this is another query we have, ID of type ID I'm passing, which is not null, and I'm returning a single user object, and that's it, user by ID. And here we can actually have sign in and sign up method. Sign up. Here either we create an input type, a custom input type, which will define the payload for the sign up, or if you don't want to do that, then you manually specify each and every attribute for the payload. String, email, and password, all are of type string. Okay, and what this will do is it is going to return token in the exchange. Let's say it's like this, and then we have a sign in. These are the mutations, and we will define these mutations in the resolver. Sign in, it will take username, or let's call it as email and password. Email and password you are passing, and it will return the user object. I mean, user object will contain the token also. Here we can just return the boolean if user has been created instead of giving a token, right? So this is sign up, this is sign in. We have created a mutation. We have, this is actually schema, right? Now we can actually create a resolver for the same. So this is a schema, and here we can create the resolver. The resolver will contain all the methods which we are going to have. So if I just simply start with export default, here we will put all the queries in this object, and here I will put all the mutations we have. So this is my query and this is my mutations. Okay, we already know what all queries we are requesting, and we are going to read all this data from MongoDB, and we are also going to understand the arguments which we are passing in the query and the resolver function. Okay, so before that, basic imports we can do from GraphQL Express, and here in this query, first query is a users, so query name should be the same whatever we have defined in the type definition. It will be a sync function because we are going to read from database. So arguments in these functions: parent, arguments object from which we will actually get the payload if you are passing something in the GraphQL query and mutation, and here we will access the context. If you see our server.js, in the context we are passing models, right? So I can access models in the resolver, and once I have these models, what I can do is I can just do the return await. I got the access of models dot, I have a user entity, user model, and I will do the find, right? This is going to return await. And for user by ID, similarly we will get the user ID in the query argument. So this is another query user where we are passing the ID and we are accessing the models from the context. This we are accessing from the arguments. Anything which you are passing, like the sign up, we are passing email, password, username, that we will be accessing from the arguments. It's like find by ID. Similarly, we have a mutation. Mutation is like we are creating the users and all, right? So if I just put that, this is sign up and it is accepting some argument, right? Sign up is the function, it should be of type async. In the async we are passing parent. Then we have the arguments object. From the argument we are accessing username, email, and password, and the second argument is the context. There we have models, and this is our arrow function, and here we will simply do await models.user.create, and we'll pass the payload, which is same username, email and password. Now you will write some logic in the Mongo's schema model to encrypt this password before saving it, and once it is done you can actually get the user here. If everything is fine, we decided that okay, we will return a boolean. Return true. You can return the user object, whole user object. In our schema definition we decided to return a boolean, so we'll follow that. Here we have a sign in. Here we are passing email and password, so we will do some query in our system to validate if this user exists, right? So await models.users.find by, so we have to write some function find by login or something, and we are passing, and we will be passing the object having email and password, something like this. Okay, if this user exists, we'll actually generate the token or we'll do something. So it's all about comparing the password, doing all the calculations, whatever you can do. Find by login, it means it will first try to find that if this email exists in our system. If true, then it will compare the password, right? Const is valid await user.validate password. So we are going to have this method in the MongoDB schema model, and we'll pass the password. If everything is fine, if we get is valid, right? If this comes out as a false, then we can actually throw custom error, through new authentication error that is coming from GraphQL authentication error, and we will just simply say invalid password. We can customize these things. If everything is fine, you can actually create a token or something. Token, I will just generate a dummy text for now. This is what you are returning, right? If you just look at the user schema, sign up, sign in, we are going to return a token, not user object. This is clear now. This is my user resolver. Okay, now in actual implementation you will have all these validate password method, which will compare the salted value of the password in the MongoDB collection with the password which you provided after validating if email exists, right? If everything is fine, you will return the token. So this is about user. Now similarly we can actually create a message. So you can actually copy this schema definition from here to the message. In the message what we are going to have is two properties. One is a text and another is a user ID who is submitting this message, that is of type string. Sorry. And we don't have more than that. We'll just have extend type query. It will say messages. If it is plural, we will return all the messages in an array format, and we can also do message by ID, and it will return a single message object. Here we can say create message, and it can be simple as what we are saying is you are passing text which is of type string and user ID, and you will return the message object. Okay, clear? So this is another type definition we have added. Similarly we will add the resolver, and finally in the next video we will combine the resolvers and type definitions. Okay, thanks everyone.